Hello everybody, this is Mr. Kusaj, and this is lesson 4-4, graphing sine and cosine functions. Don't forget the date here. So what we want to do now is, we've been working with the sine and cosine. What we want to do now is look at the graphs for sine and cosine. So if we graph, if we graph sine of many angles and connect the dots, what will that graph look like? And same thing with cosine. So we'll do those two first. Let's start with just plain old sine x. We'll move on to where there'll be numbers around here and it'll transform it. But what does the basic one, the parent graph of sine x look like? Well, hold on to your seats. It looks like this. Okay? So you can pause here and copy it. And after you've finished copying it, let's notice a few things about it. First, notice that on the y-axis, up and down, it only goes one up and one down. It never goes past one up, past one above, and past one below. See that? Always, the furthest down it goes is -1, and the furthest up it goes +1. That's the first thing to notice. The next thing to notice on the x-axis is we have radians. Now we can't put, we can't put every single angle, so we put some major ones, or what do you want to call them? Common ones or special ones. So the ones I included here were every half pi. So 1/2 pi, 2 halves, 1 pi, 3 halves, 4 halves, which is 2 pi. So this is a complete circle. And it makes sense that after you go once around, you start repeating the cycle. Okay, so the sine function repeats every circle, every 2 pi, right? So notice that it's 0 at the beginning, and 0 in the middle, and 0 at the end, which is really the beginning of the next cycle. And notice that right in the middle of the zeros is all the way up or all the way down. So it's very symmetrical. Okay? So we'll talk more about it, but when you sketch, the easiest sketch to do is, if you're in a rush, would be just to put pi and 2 pi, right? So if I had to sketch the sine graph really quick, I know it starts here, I know it goes through here, and it ends here, right? So up, down like that, and I'm going to limit myself to 1 up and 1 above, so like that, right? So if you want to be more accurate, you put more, more angles in between here, and you have a prettier graph. But basically, we usually go up to 2 pi and show one cycle. Okay, what about the cosine? The cosine looks a lot like sine x, except instead of starting at 0, it starts at 1. So remember, sine started at 0 and went to 1. This one starts at 1, then goes to 0, then down, then back to 0 and back to 1. And then it repeats. So notice that it starts at 1 and ends at 1, whereas sine starts at 0 and ends at 0. Okay? And by the way, you should know these common angles by now, but if you put in your calculator cosine of pi, it'll say -1. If you put in your calculator cosine of pi over 2, it will say 0. If you put cosine of 0, it'll say 1. If you put cosine of 2 pi, it'll say 1. That's how we got these values. And then everything in between, right? Okay, so these are the basic, the parent graphs of sine and cosine. All right, so now let's look closer at what putting numbers around the function does to the graph. Okay, transformations. We're going to take the basic graph and do things with it. Move it around, stretch it, squish it, all sorts of things like that. So first thing you need to know is if there's a number right in front, multiplier, right? Right in front of sine x, what it does is it stretches it, right? It makes it taller. That's called the amplitude. So that little number is called the amplitude number. So for example, notice that this graph has an amplitude of 2. That means instead of sine, right? Instead of my sine graph going only up to 1, I stretch it all the way up to 2. 2 above and 2 below. So my amplitude is 2 here. Right? It's not sine x, it's 2 sine x. Because sine x would only go on up to 1. 2 sine x goes up to 2. What if it's half here? Then exactly what you think. Instead of going all the way, it starts at 0. Instead of going all the way up to 1, it only goes up to half. Instead of going down to 1, it only goes down to half. So the amplitude means how tall from the midline, from the middle, how tall is it? Well, this one has to be 2 tall. This one has to be half tall. Right? What about the cosine? Same thing. Instead of starting at 1, right, we're going to start at 2 here. And instead of dipping down to -1, we're going to dip down 2. So the amplitude is 2. From the middle, how tall is it? 2, 2. Okay? Now, before we go on, notice that a complete cycle of sine looks like a perfect S, right? Well, for cosine, this is a complete cycle. I know some people like to think like, oh, where's the S? Well, a complete cycle is when you start repeating. So it looks like some sort of V or a U shape, but that's a complete cosine cycle, right? Starts, ends at the same place. But the sine looks like an S. So what I have here is one complete cycle. I know I'm missing the numbers here, but this would be one complete cycle. Right? Okay, so that's the amplitude. How tall are you from the midline? That's that number there. Okay? Now, reflections. Now we know this from other functions, like the quadratic function. Remember if you had like negative x squared, it'll flip over, it'll go down. Remember that? Same thing here. So you know what sine x looks like. If you have a negative in front, it'll just flip it over. Look. So you know what sine x looks like. If you have a negative in front, it'll just flip it over. So this was on top, now it's on the bottom. This was in the bottom, now it's on top. So it's a reflection. It's a reflection. Imagine this being the mirror, and it reflects over the mirror. Okay? Here's how cosine would look like. Now here, not only do we have a reflection, but we also have an amplitude. So not only are you going to reflect this, but it's 2 units tall, right? So instead of going 2 up, instead of starting at 2 up, you start at 2 below. Instead of reaching all the way down to 2 below, you reach all the way up to 2 above, etc. Right? That's reflection. That's what happens when you have a negative in the front. So now we know what happens when you have a number and a negative in the front. Amplitude, reflection. Okay, so can you try, before I see you next time, try these? Just graph them on the same axes. Graph these two on the same axes. Make one of them dotted and one of them solid. So this is cosine x. Just copy the notes. What would negative half cosine x look like? The amplitude here is half, and it's flipped. Here's sine x. What would negative 2 sine x look like? Okay, I'll give you the answers next time I see you. More transformations. No, that's it for part 1. There's more about this in part 2. So let's take a break, and I'll see you for part 2. All right, bye.